text detection. Okay, so right now what we are going to focus on this session is what text detection is. And like, you want to chat? And any questions?
No.
Okay. So text detection, why text detection is needed is because one problem which we are trying to solve is OCR. So in OCR, if you take end stage pipeline, the first step is text detection. So in text detection, you can actually classify it into like two types. One is document text detection, and the next one is natural seed. So if I take a photo and I point my camera and I take a photo and I just feed it to an algorithm to detect the text, then that is called natural seed. Because we are just taking a scene there it's not like predefined lighting or something. Everything is as it is, just like a rice. So that is called natural scene. Document is it's pretty easy because it's just black and white. So you can think document as PDF. So if you want PDF, we go for a different algorithm, but we actually have to solve this problem. Why? Because most of the documents which we get are natural scenes. Like you just take a camera and you take a photo, you shoot a photo, right? So that is the context. So we are going to focus on natural scene text detection. So they just call it scene text detection.
If you take a photo of an ID card,
That is classified as the natural scene, right? Because the photo you are not expect to make an ideal lighting. It can be any lighting. It can be here. It can be in the town also. So if you just scan an ID card, then it is called document text detection. But if you not even scan, even scanning can be taken as a natural scene because the reason is the ID card may not be of optimal quality. So if you can think PDFs are a good example, like the papers, the archive papers, those kind of actually are natural scenes. Sorry, or documents. Okay. So text detection. So text detection actually they are trying to solve it in 2000s. Now in 2012 after AlexNet they came with some deep learning models. So here now we start with deep learning. So text okay. So suppose if I want to detect this as a text and if I want to detect this, so you can actually detect different instances of it. So if I take this, this is called word level. If I want to take this, this is called a part of segment. Or if I want to take the entire thing, this is called line level. Or even if I want to take a single character, it is called a single character level. So if in most of the data sets, like we have ICDR 2013, 15, 17, 18, 19, those actually, most of them have word level annotations. 18 is there? I think 18 is there. No, I don't think 18 is there. Yeah, 3 years there, 2 years. 3 years. So if you take, these are actually word level bounding boxes. And most of the annotations are designed to be word level bounding boxes. Why they think word level bounding boxes is because when you read something, you don't actually spell text, you just take text. And it is easier to annotate because for different fonts, like annotating every character is like impossible. Like it's not impossible, it's really difficult. So they actually annotate this whole text. Okay. Now, so at first we wanted to solve the problem using word level.
Who is
He as in most of the people who have worked in text detection. So if you see majority of text detectors out there, like people try to solve the problems using word level because two things. Word level we have a lot of annotations. Second is word level is easy to converge. If you take an example word level, but there is a problem. So okay, just keep that. So if you go for deep learning steps, there are majority, not like 90% of people try to solve it this as an object detection. So because you can think of text as an object, right? Because you are given warning boxes, you are actually labeling them as x1, y1, some x2, y2. So people try to solve this problem using object detection. So like object detection, like majority of the papers, or you could try to solve this using segmentation.
give examples of papers?
Okay. In object detection, like there is rotated RCN, FRCN, yeast, then okay, words up, then like most of all the papers like have and some for I don't know. For segmentation, pixel link, like link for graph, pixel link, then I think one more segment, yeah. Okay, so whatever has linking there, it actually it's part of segmentation. So why will you come back to it? So if you see rotated RCN east towards a graph, they are actually object detection, right? So the problem of object detection when you take text is if the text is say 250 characters, it won't converge well. Why? So the object detection is based on anchors.
If the text is 250 characters.
And it's like really long text. I'll say why. It's 250 characters as in like if it's really long
You mean
text,
one word is 250 characters?
or text line or a text, yeah. A word can be 250 characters, right?
You meant a single word, no?
Single word. Or single line. Anything like whichever you want to predict, right? If you're taking text instances, it can be 50 characters. Or if your model wants to predict lines, if the line is 256 characters, then also it is actually for you, you are annotating the ground truth as a line. So that line you are considering an object. Or you can annotate a word bounding box and you think that can be also a, say pure annotation, that depends upon you. But since object detection here we are actually basing this on anchors and any other approach for object detection.
Two streams.
But the base is labeling, how do you do? Anchor string. Is there any other way? Okay, corners. That's all. I think SSB also. Okay, so if you're going to take anchors, how you. Okay, is everyone clear with anchors? Huh? No. Okay, so objects, if you take this human, so he's in the screen. So anchors are just points. This is like layman's terms, not really the accurate presentation. So these are called anchors, and every anchor will have one aspect ratio. So it goes on. And if you want to detect this person, like you have to ensure that the the area over IOU. So what object detection does is it actually scans these anchors and it actually gets the maximum IOU of all the n number of anchors. if there are like n anchors, so you get it right. There's like three into n. So n number of anchors. If the IO is great, you take that anchor as the bounding box. That is actually anchors. Okay, so now the problem is text. If it's like really long, or if the font is like this, it's really difficult to draw. It's actually difficult to draw anchors. Like construct anchors for different kinds of text. One can be this kind of a text, or one can be, or one can be. The problem is the aspect ratio is not pretty defined. So creating anchors is really difficult. And when you come for 250 word length,
You have to tell the anchors are hard-coded aspect ratios.
aspect ratios, right? That's what I said.
Hard-coded. It's not learned.
It's not learned. So that's what these are like 9 different anchors you can get.
It's fixed in the beginning. It's fixed in the beginning.
You have to fix and then
Because these are fixed points, right? You are fixing the points, you are fixing the anchors, you are actually also fixing the size of the anchor. Like if this is 3 pixels, you are actually specifying this. You don't specify just 3, 3, you will specify 3, 9, 12, 3 anchors, 3 aspect ratios. 1:2, 2:1, then 1:1. So you are actually using 9 anchors for aspect ratio.
3, 9, and 12 is the filter size.
No, it's anchor size. 3 and 12 power will filter size.
Filter is what the anchor.
Anchor is not filter, right? That is coordinates is not.
Pixel size.
The anchor resolution. Okay. Filter is not in terms of viewing. It's not CNN filters. Okay.